All right, here we go. Now comes to part two, where you actually need to know what is in the EM wave spectrum and what they're used for. Right. So if you look into the syllabus guide, you're gonna say, hey, I need to look at applications of the EM waves. I need to list all of it. You describe the main regions, in order of wavelength and frequency, and tell all this. In many ways, this seems like a memorization chapter. Well, kind of is lah, right? So let's try to find a way such that all these can be easily remembered. And I'm going to do it this way. Let's first write out everything that we need to know for the electromagnetic wave spectrum. Now, there are these 7, right? One way you need to do it is that you need to find a sentence and remember all these things. Now, in school, I was taught this that doesn't make sense, but kind of works, right? It's go, cross, like cross, under, valley, I am right. That makes no sense, and yet it works so well, right? Another way that I learned is going the other way, right? RMIVUXG. Ronald McDonald is very unique, extra good. Now, why is this important to know? It's because right now, the order in which you write it out is very, very important. Okay, now each of them means something. So let's go from the top to the bottom. I'm just going to pause and write out the names because this is a revision video. Here we go. And there you go. These are the 7 you must remember. So figure out which way you remember it, either from the G or from the R, but the order is something that you need to know first and foremost in this chapter. Okay. So now that I've written it out, I'm going to put it aside. Maybe I won't put it sideways. I'll leave it this way. Now, what must we know now? I need to remember that these things all travel at the speed of light, but they are arranged based on their frequency and also based on their wavelength. So every single one of these has a very unique frequency range. Is it important to know what the range is? Not quite, right? But it's important to know this part. I'm going to draw 2 arrows, one this way, one that way. The arrow direction is going to indicate increasing, okay? Increasing in something. So I'm going to say for the one on the left, maybe I'll use a different color. Maybe let's use this color, okay? Yeah, that looks much better. Oh, very good. All right, so what is increasing in this direction, in this direction? Now, as I go from radio waves to gamma waves, what increases would be frequency. That is way too big. Let me make it smaller. Very good. Frequency. So now, what do you call frequency over here, right? We call this low frequency, and we call this high frequency. Okay, it's not small frequency, big frequency. Yeah, it's low frequency, high frequency. Right? That's to say, radio waves have very low frequency, and as we go up the spectrum, gamma rays has the highest frequency. Now, how is that? Why is that important? We'll learn it later. But right now, it's about the order. It's knowing what are the characteristics as we look at this order. Low frequency, high frequency as you go from radio waves to gamma rays. Now, on the other side, the blue color arrow, what's increasing in that direction? I'm looking over here at, wait for it, hint, V equals to F lambda. Oh, that's a really ugly looking V. Let me do it better. V. That doesn't look much better, right? So velocity, frequency, wavelength. I know that all of these have all the same speed. They all travel in a vacuum at the speed of light, correct? Now, if frequency is increasing in this side, if frequency increases in this side, so look at this one over here. Imagine this one. This is 3 times 10 to the power of 8 meters per second. That's the speed, correct? It has a really, really high frequency. What do you know about then the wavelength of this one? Yep, as you have guessed, this part talks about wavelength, right? So the comparison is now this: when the wavelength is short wavelength, I'm going to have a very, very high frequency, right? But what's the opposite of short? Long, correct? I'm totally answering my own questions because this is a video. Hey, right? So when the frequency is low, the wavelength is long. That's one way to remember: low, long. right? So this is how it's ordered. Now, once you remember that this is the order and that is ordered in terms of increasing frequency or increasing wavelength, the next part is to know, what is it for? What are the applications of this? Right? So you have the applications over here. Of course, I can just say, ta-da, video is done, read it, and there you go. But I'll go through this very quickly with you. Right? Once again, the main part of this is I know that there are 7 different electromagnetic waves in the spectrum. These 7 are gamma, X-ray, gamma rays, X rays, ultraviolet, visible light, infrared, microwaves, radio waves. And they are arranged in a very specific order, such that as I go from R to G, radio waves to gamma rays, it's one with increasing frequency, low to high. And if I look from gamma to radio waves, it's one goes from short wavelength to long wavelength, right? How to visualize this, how to remember this, that's done in class. This is just a recap. Now that I've talked about these 7 components, we ask ourselves, hey, wait a minute, I remember about color spectrum. Where is my color spectrum? Where is my red, orange, yellow, green, blue, no, Roy G. Biff. Red, orange, yellow, green, blue, indigo, violet. Where do I find it here? Where? It's actually here, invisible light. So I'd like you to also look over here. Look very carefully because you can find, what did I just do? Let's try again. Aha. Let's look at where I can find the colors of the rainbow, so to speak, inside this spectrum. And actually, the answer is right there. Do you see it? Visible light consists of the 7 colors. So what is the order of the colors? We remember using that phrase, Roy G. Biff. What a name. Mr. Roy G. Biff. All right. So we use it over here. We're going to start with red. Where's red? Ha! Right? So let's go. Red, orange, yellow, green, blue, indigo, violet. So what you're doing is that you're using the words over here to remind yourself what is the order when I'm looking at visible light. Why is it important? Is because, hey, if I am able to get this order out in this very specific manner, I'm able to tell myself or find out which color has the highest frequency and which one has the lowest frequency. So let's zoom out a little bit and you might be able to tell. Since violet is higher up on this spectrum, it will have a higher frequency compared to red, right? Which means red would have a longer wavelength compared to violet, right? So we have done double list. The first list would be my go cross undervalue IM, right? Or Ronald McDonald is very unique, extra good. This is so embarrassing, right? The other list, remember, is Roy G. Biff, right? That's the 7 colors that makes up light, right? So you have this and you have that, and you know the order in terms of its frequency and the order in terms of its wavelength. Increasing frequency, increasing wavelength. Okay, now to end off, let's do a very quick look. Did I just shift everything? Oh no. Okay, there we go. Let's do a very quick look at the uses, the applications of it. Right? Just use my read by itself. Radio waves, we use it for video and television communication. I would like you to remember that we distinguish radio waves in terms of communication different from microwaves, which is your mobile or cell phone communication. So think of this radio waves as just video and TV, but microwaves, that's where you have like your satellite television, where things which are shown all the way in US, you can see it in Singapore because of the satellites, right? So more importantly, right, your cell phones uses microwaves to transfer information. So radio waves would be for television communication, but it is not cell phone communication, right? Please make sure you make a difference. Now, can I say microwaves is for microwaves? Let's be clear, okay? Microwave ovens uses microwaves. So do not say, what is the application of microwave? It is to microwave. Please don't say that, all right? It's used in a microwave oven. Now, infrared is, I think the easiest one to remember is that, well, when you do temperature taking, when you use those digital thermometers, well, that's one of the things it's used for. But inside your textbook, they think of it in terms of the remote controllers and intruder alarms, right? Remote control intruder alarms are the easiest to remember, right? Thermal imaging is like when you play those games and then you put your thermal goggles and you can see the people moving. Yeah, that's infrared. Visible light, do not say visible light is for me to see. No, all right? The usage of it, right, would be in photography, in optical fibers, in medicine and telecommunications. So just remember, visible light, one of the applications is in photography and use of optical fibers. Now, ultraviolet, okay, what is very commonly used would be for sunbeds, where you can tan yourself artificially. But of course, the more interesting one would be banknote authentication. That's where you put your money underneath this black light, which is ultraviolet, and then you can see a special mark coming out. Uh, During COVID time, we use ultraviolet rays to disinfect surfaces and water, right? So this is still done, ultraviolet. X-rays is for you for medical radiology, right? I can say for security screening and industrial defect detection. It just means to check for cracks within those industrial things, right? What is easy to remember? Security screening. And finally, gamma rays, what's it for? We can say it's for detection of cancer and treatment. What you can remember, you could say cancer treatment. That's one way, right? In some cases, it's used to sterilize food. Okay, that is 12 minutes. We have gone through how do you remember everything you find inside the spectrum, right? These 7 things, I'm moving the wrong things, and its application. There you go. Well done.